This is your instructor in EE130 or the DC and AC machineries. So chapter 1, I already posted materials regarding chapter 1 and also the lecture. We are now into chapter 2. So first, we will discuss the types of DC generators. Due to residual magnetism, there is always present some flux in the poles. So generators are usually classified according to the way in which their field windings are excited. So generators may be divided into letter A is the separately excited generators and letter B is the self-excited generators. So what is a separately excited generator? So those whose field magnets are energized from an independent external source of DC current. So as you can see here, the separately excited DC generator, its field windings, this F1 and F2, the 20 field windings, na they are excited by the external DC supply. And the other one is the self-excited generators. So are those whose field magnets are energized by the current produced by the generators themselves. When the armature is rotated, some EMF and hence some induced current is produced, which is partly or fully passed through the field coils, thereby strengthening the residual pole flux. The first type of DC generator under self-excited is the shunt wound DC generator. So in shunt wound DC generators, the field windings are connected in parallel with armature conductors as shown in the figure. In this type of generators, the armature current IA divides into two parts. In shunt wound, the output voltage is inversely proportional with load current. One part is the shunt field current flows through the shunt field windings, and the other part is the load current IL goes through the external load. This is the circuit diagram of a shunt wound DC generator. So this is what we call the shunt field resistance, or we will designate it as RSH, and it is in parallel with this generator. So isungan ako ng shunt resistance because shunt is the other term for parallel. And also the load, the external load is in parallel with the generator. This load may be mabalin nga dagijay silaw yo or electric fans, any electrical equipments that is connected to the generator. And this voltage here is what we call the terminal voltage or VT. So this one is what we call the output voltage of the generator. So dito nga voltage isuti kasapulan ni load mo nga voltage. Okay, example, in our home, our terminal voltage in the convenience outlet is 230 volts. So that is the output voltage. Okay, so as you can see here, we will examine this circuit. So this is the generator. What will be the equation of your IA? We will rewrite this circuit diagram. Mabalin nga ito ni shunt mo, shunt resistance And then this is your generator. Connected to the load. And it has an output voltage VT. Inside of a generator, there is what we call armature resistance. So armature resistance, RA. So inside the generator. So this is EG. EG is the generated EMF or voltage of the generator. So since this is a generator, diba, EJ chapter 1, it supplies current. It supplies voltage. So the direction of your current here in EG will be upward kasi isu iti mang supply kani RSH and your load. So since at the iti RA EJ o nagti generator, our current will be designated as IA. So IA is the armature current. And then it will supply RSH. So RSH at the ET designation ng current niya, ISH. So RSH is the shunt resistance. And ISH, shunt current. And also, this generator supplies current in the load. So, since this is a load, we will designate it as IL. So, IL is equal to the load current. From your circuits, last sem or last sem, you encountered the word KCL, diba? Kirchhoff's current law. KCL. So from here, from this node, ito yung node, dati ma-formulate tayo nga KCL. So current entering is equal to the current leaving, KCL. IA, it is equal to ISH plus IL. ISH equal to terminal voltage divided by RSH. We can rewrite this one in terms of battery. So this is your RSH, battery. Kamno no mas maawatan nyo. Load. And terminal voltage. RA is the internal resistance of the generator. So, mangikabil tayo tinaka-series nga RA. This is your EG. The direction of current of RA is upward, IA. This is ISH. And then current to load. This one is RSH. Okay. So kung natin tatay ISH, the current here is equal to the terminal voltage divided by your shunt resistance. And mabalin mo met pay nga ano mo nga magets deta nga circuit. Mabalin mo pay nga i-rewrite ito ni battery or ni generator. Parallel, this is your RSH, and your load, and then the voltage across the load is your terminal voltage. This is your RA, EG, current IA, current ISH, and load current. EG now will be equal to the terminal voltage plus the drop in resistance plus the drop in the brush. So this is voltage drop in brush. And also power generated at the generator. Generated power, it is equal to the generated voltage multiplied by armature current. And you can solve IL, nohan nga given ni IL, it is equal to PL all over VT. PL is the load power. So example number 1. The no load voltage of a 50 kilowatt 220 volts shunt generator in the FEU laboratory is 232 volts, and the rated load voltage is 220 volts. The armature resistance including brushes is 0.026 ohm, and the resistance of the shunt field is 52 ohms. What is the induced electromagnetic force at the rated load? This is the circuit diagram of a shunt generator. So these are the brushes. And field or shunt resistance and your load. Terminal voltage VT across the load. It's your EG plus minus. The direction of current is upward. So this is your IA, and we have an internal resistance RA equal to 0.026 ohm, including brushes. So your ISH downward, and your load IL. value of RSH is equal to 52 ohms. The load power is equal to 50 kilowatt, and it has a terminal rated voltage of 220 volts. Also, RSH 52 ohms, RA is 0.026 ohms. Required, what is the induced electromagnetic force at the rated load? So required is the EG, generated voltage. Our working equation here, EG will be equal to, since this is a shunt generator, Vt plus the drop in armature plus the drop in brush. But the drop in brush is already included in the armature resistance. So we will equate this equal to 0. Unknown here is the IA. How will we solve IA in shunt generator? So IA from this node, diba? KCL, IA is equal to ISH plus IL. ISH is equal to Vt divided by RSH equal to 220 volts divided by 52. ISH is equal to 4.23 amperes. And IL, since load power is given 50,000 divided by the terminal voltage equal to 220, so we have a load current equal to 227.27 ampere. IA now will be equal to 4.23 plus 227.27, so IA is equal to 231.5 amperes. So we are now ready to solve the generated EMF equal to 220 plus IA 231.5 multiplied by the armature resistance equal to 0.026. So EG now will be equal to 226.02 volts. Our next topic is the series wound DC generator. So in this case, the field windings are joined in series with the armature conductors. In series wound generators, the output voltage is directly proportional to the load current. As they carry full load current, they consist of relatively few turns of thick wire or strips. Such generators rarely used except for special purposes such as boosters. So as you can see here, the series field of the DC generator is in series with the generator. So, mabalintay nga i-rewrite dito. Tamno no Mamaya, i-redraw. This is your generator, positive and negative. Connected to the load. And across the load is your terminal voltage VT. So ano ko ng series wound kasi naka-series ni field windings. This is your RSE. So RSE stands for series field winding. Series field winding resistance. Again, the direction of current is from negative to positive. This is your EG. Inside the EG, there is what we call again armature resistance, RA. Always nga the armature resistance na ija o negative generator. The flow of current will be from negative to positive. We can see here that your IA, this is your IA, direction of ISE, diba? RSE data, ISE data. And then the direction of your load current. RA, RSE, and the load resistance is in series. Therefore, IA is equal to ISE and it is equal to IL. I-redraw tayo into battery generator. This is your load, terminal voltage at across the load. That in RA, internal resistance or armature resistance, EG, and RSE. So, in IA, ISE, and IL. EG now will be equal to the terminal voltage plus the drop in armature resistance, so that is IARA, plus drop in series resistance, IARSE. Simplify, EG will be equal to VT plus IA multiplied by RA plus RSE. Same, generated power is equal to EG IA. Ito gayam ada iti plus VB na brush drop. No ada ti in specify ni problem nga brush drop kabilyod tangim no awan equate it to 0. Brush drop data. So, kastoy lang ni series wound DC generator.